All right, hello and welcome back everyone. This video covers the Day 10 Level 2 Graphing Exponentials and Logs. In question number 1, we're graphing an exponential function and it's y equals 2 times 3 to the x minus 1 plus 4. First, we want to look at the parent function. The parent function is just going to be y equals 3 to the x. So let's graph this by making a table first. In the table, we're going to choose our x values. We can choose our x values when it is an exponential. So the x values will go from -2 to +2. And then we'll just plug in each one of the x values into the equation to get y. So y would be 3 raised to the -2. That's going to be 1/9. Y equals 3 to the -1 is 1/3. 3 to the 0 is 1, 3 to the first is 3, and 3 to the second is 9. Now we also have to consider the a times y column. The a would be the coefficient in front of the 3, which is 2. So we're going to multiply all of these y values by 2. That's going to give us these values here. 2 times 1/9 is 2/9. 2 times 1/3 is 2/3, 2 times 1 is 2, etc. All right, now we're going to go ahead and plot those points. All right, now what are we plotting? We're plotting the x coordinate with the a times y coordinate. So that's -2, 2/9. We're plotting -1, 2/3. We're plotting 0, 2. We're plotting 1, 6. And then we're also plotting 2, 18. All right, and those are the points that we can fit on the graph, and this is the exponential curve. As usual, we have a horizontal asymptote for exponential functions. All right, the next thing to do is to graph the transformation. Now this graph is moved to the right 1 unit and then up 4 units. So all you have to do is first move your horizontal asymptote up 4 units. So instead of it being at 0, the horizontal asymptote is up here at 4. And then take all of these points and move them over to the right 1 and up 4. And that's exactly what you're seeing here. All right, and that is your completed graph. Now down here, it's asking for the horizontal and the vertical movement. Well, horizontally, it moved to the right 1, and that's because of the x minus 1 here. That moves to the right 1. And the vertical is moving up 4 because of the plus 4. And then we want to do the domain, range, and asymptote. Well, the domain goes to the left and to the right forever, so that's -infinity to infinity. The range goes from the horizontal asymptote all the way up to infinity, and the horizontal asymptote is at 4, so it'll go from 4 up to infinity. And then the horizontal asymptote is at y equals 4, so that's your equation for the horizontal asymptote. All right, so that is the first graph. All right, here's our first practice problem. So we're graphing number 1, and it's y equals 1/4 times 2 to the x. Well, first, let's look at the parent function. The parent function is just going to be y equals 2 to the x. We'll take care of the 1/4 later when we do the a times y column. All right, let's go ahead and make a table for this. So we have x's. We're going to choose our x's first because this is an exponential equation. We'll plug in the x values to get y, and then we'll take all of the y values and multiply by 1/4 to get the ay column. All right, so our x's, let's go from -3 to 3. Maybe we'll go one more, -3 to 4. All right, plugging those in, 2 to the -3rd is 1/8. 2 to the -2 is 1/4. 2 to the negative 1 is 1/2, and so on. So the complete y values are 1/8, 1/4, 1/2, 1, 2, 4, 8, and 16. Now let's multiply all of these y values by the coefficient of 1/4. And we get the numbers here in this column. So that's 1/8 times 1/4 is 1/32. 1/4 times a fourth is 1/16, and so on. All right, now we're going to go ahead and graph this. What we're graphing is the x-coordinate and the a times y coordinate. So we're graphing the point -3, 1/32. And then we're going to plot -2, 1/16, and so on. All right, when we plot those points, we get this graph. All right, so that is our completed graph. We have the horizontal asymptote here at 0, and it levels out here on the left, and then it goes up on the right. All right, we're going to determine the domain, range, and the horizontal asymptote. Domain, since the graph goes to the left and to the right forever, that's -infinity to infinity. And the range is going to go from the horizontal asymptote, which is at 0, all the way up to infinity. So that's your range, 0 to infinity. And the horizontal asymptote is y equals 0. All right, next we're graphing number 3. That's 5 times 1/2 raised to the x plus 1 minus 1. All right, first we're going to graph the parent curve. The parent curve is just going to be 1/2 to the x. Let's make our table. Table is going to have the 3 columns with x, y, and ay. We'll choose our x's first. So that's going to go from -3 to 3. 1/2 to the -3 is 8. 1/2 to the -2 is 4. 1/2 to the -1 is 2. And so on. So we have these values for y. And then the a times y, the a is 5. So we're multiplying all of these y values by 5. So 8 times 5 is 40. 4 times 5 is 20, and so on. So we get these as our a times y values. Now we'll go over to the grid and we'll plot the x-coordinate along with the a times y coordinate. And we'll just fit all the points that we can get on the graph. Okay, so this ends up being our graph. This point right here is 0, 5, which is right there. This point is 1, 5/2. This point is 2, 5/4, and so on. All right, so this is the parent curve. Now, what is this transformation doing? Well, we know about the 5. We know that's a vertical stretch, but we don't need to mention it because we've already got that in the a times y column. We just need to mention the x plus 1 and then the minus 1. Well, the x plus 1 is going to move the graph to the left 1 unit, and then this minus 1 moves it down 1 unit. So together that's to the left 1 and then down 1. So we simply take this graph, move it everything to the left 1 and down 1. Now when you move it down 1, the horizontal asymptote will also shift down 1. So here's the end result of the graph after the transformation. All right, so we moved it down 1. We also moved it to the left 1. And you see the horizontal asymptote here is down 1. All right, what is the domain, range, and horizontal asymptote? Goes to the left and to the right forever, so the domain is -infinity to infinity. The range goes from the horizontal asymptote at -1 all the way to infinity. And the asymptote is y equals -1. All right, next we're graphing question 5, and it's y equals 2 times 3 to the x minus 2. We'll graph the parent function first, which is just y equals 3 to the x. And we'll create a table. We're going to choose our x values first. Let's go from -3 to 3. 3 to the -3 is going to be 1 over 27. 3 to the -2 is going to be 1 over 9, and etc. So here are the resulting y values. And then for the AY column, we do have a coefficient of 2. So all of the y values are going to be multiplied by 2. So 1 over 27 becomes 2 27ths. 1/9 is going to become 2/9, etc. And the 9 is going to become 18. So here are all of the a times y values. All right, let's go to the grid, and we're going to plot the x and the AY points together. All right, here is the result of plotting those points. That's plotting the x column along with the AY column. All right, that's what it looks like. Now let's apply the transformation. Well, we've already talked about the 2. We've already applied the 2 in the a times y column. So the only other thing to talk about is the -2 on the end. And that moves the graph down 2 units. So we're going to go down 2. So just drop everything, including the horizontal asymptote, drop everything down 2 units. And this red curve is the result of dropping everything down 2 units. All right, let's talk about the domain, range, and asymptote. All right, so the domain goes from -infinity to infinity because the graph goes to the left and right forever. The range is going to go from the horizontal asymptote all the way to infinity. So that means it's going to be from -2 to infinity. And then the horizontal asymptote is y equals -2. All right, now we get into graphing logs. All right, we've talked about this before, but let me remind you. When you're graphing logs, first you want to write it in its parent function first. So here we have 2 log base 2 of x minus 3 plus 4. The parent function would just be y equals log base 2 of x. So log base 2 of x is our parent. Now let's convert that to an exponent. So in the exponent form, it's 2 raised to the power of y equals x. Now because y is the exponent, when you're solving logs, you want to choose the y column first. So the y column, let's go from -2 to +2 there. And when you choose the -2 and plug it in, that's 2 to the -2 is going to give you 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the second is 4. All right, so again, you establish your y column first, and then plug that into the exponent to get x. All right, now we also have to do the a times y column, and there is a coefficient of 2, so everything in the y column gets multiplied by 2. And the resulting numbers are -4, -2, 0, 2, and 4. All right, let's go ahead and plot this parent curve. And this is what it looks like. For log graphs, you always have a vertical asymptote going through 0 for the parent curves. The points we're plotting are x equals 1/4 and y is -4. That's this point right here. And then we're also plotting 1/2 comma -2. That is this point here, and so on. So these are all the points that we can fit. Now let's talk about the transformation. In the equation, the x is being subtracted by 3, so that moves it to the right 3. And then the positive 4 moves it up 4. So the transformation is to the right 3 and up 4. So we'll just take everything on this graph and apply that transformation to it. After the transformation, the vertical asymptote moves to the right 3. So there's our new vertical asymptote. And then we moved all the points to the right 3 and also up 4. So that red curve is our final curve. All right, and then let's answer the questions here at the bottom. Horizontal and vertical is just asking for what is the horizontal and vertical movement. Horizontal is to the right 3 and the vertical was up 4. Our domain is going to be from the vertical asymptote to infinity. So that's going to be from 3 to infinity. Range, since the graph goes down and up forever, that's negative infinity to infinity. And the vertical asymptote is at x equals positive 3. All right, graphing another log equation and then determining domain, range, and vertical asymptote. All right, so it's log base 3 of x minus 1 plus the 4. First, let's rewrite it using its parent curve. The parent curve is just y equals log base 3 of x. Convert that to an exponent, and we get 3 raised to the y equals x. Then we'll generate a table, and of course, we want to choose our y column first, and then the x's. Now I'll just show all of it at once. So typically, you'll put your y column in there first, and then plug that in. So 3 raised to the negative 3 is 1 over 27. 3 raised to the negative 2 is 1/9. And 3 raised to the negative 1 is 1/3, and so on. All right, we don't have a coefficient, so we can actually just leave the AY column blank. All right, let's go ahead and plot the points over on the grid. And this is what the graph looks like, plotting those points. Now let's talk about the transformation. The x minus 1 moves it to the right, and the positive 4 moves it up. So altogether, it goes to the right by 1, and then up by 4. Plotting the transformation, we moved all the points up 4 and also to the right 1. And as you can see, the vertical asymptote has moved to the right 1 unit as well. All right, so that red curve is your graph. Now, what's the domain, range, and vertical asymptote? Domain is going to go from the vertical asymptote of 1 all the way to infinity. The range goes down and up forever, so that's negative infinity to infinity. And the vertical asymptote is at x equals 1. All right, in number 9, we're graphing log again, and it's log base 3. So the parent curve is y equals log base 3 of x. It's one we just did. Of course, you're going to convert it to an exponent, so 3 to the y equals x. We'll make our table, and we're going to choose our y values first, going from negative 3 to 3. So 3 to the negative 3 is 1 over 27, and 3 to the negative 2 is 1 over 9, and so on. So we get these x values here. Now we have an a times y column, and we do have a coefficient. So the coefficient's 2, so all of the y values get multiplied by 2, and these are your resulting AY values. All right, so when we plot the points, we're going to plot the coordinate 1/27th, comma, -6, and then 1/9th, comma, -4, and so on. All right, so plotting the points and connecting the dots, we get this curve here. Again, this is our original parent curve. And now let's talk about the transformation. We already know about the 2, the coefficient of 2, that just does a vertical stretch. But we've already have that in the AY column, so we don't really need to mention that again. But let's talk about the plus 3. The plus 3 is going to move the graph up 3 units. So let's take the original curve and just shift everything up 3 units. And the red curve is the resulting curve. Now let's talk about the domain, range, and vertical asymptote. Domain starts at the vertical asymptote of 0 and then goes to infinity. The range goes down to negative infinity and then up to positive infinity. And the vertical asymptote is just x equals 0. All right, ladies and gentlemen, here's number 11. And we have log base 5 of x plus 5 minus 4. The parent curve is just going to be y equals log base 5 of x. We'll convert that to an exponent. So that's 5 to the y equals x. We're going to create a table. And we're going to choose our y values first. And that's going to be from negative 3 to 3. And of course, when you plug negative 3 in, that's 5 to the negative 3 would give you 1 over 25. 5 to the negative 2 is 1 over 25. And 5 to the negative 1 is 1/5. And so on. 5 to the 0 is 1. 5 to the first is 5. 5 to the second is 25. And 5 to the third is 125. All right. We don't have a coefficient in front of the log, so we can leave the a times y column blank. And let's go ahead and plot the points on the grid. Plotting the points and connecting the dots, we get this curve. All right, now let's talk about the transformation. The x plus 5 moves everything to the left, and the minus 4 moves down. So it's left 5 and down 4. So when we move to the left 5, the vertical asymptote will now be at negative 5. And then we'll also move everything down 4. So the resulting graph looks like this. All right, so that red curve is your final graph. And then let's talk about the domain, range, and the asymptote. So your domain goes from the vertical asymptote at negative 5 all the way to infinity. Your range goes down to negative infinity and up to positive infinity. And your asymptote, as we said, is x is equal to negative 5. And here is number 13. We have y equals the natural log of x minus 1 minus 2. The parent curve is just y equals the natural log of x. And we know the natural log is actually log base e. So when we convert it to an exponent, it's e raised to the power of y equals x. So you just have to remember that natural log is log base e. All right, let's generate our table. And of course, we're going to choose the y values first. And the y values are negative 3 to 3. And then now, how do we get the x coordinates? So again, we chose the y values first, and then we've got to get these x coordinates. Well, we have to use our calculator. So let's show you how to do that. All right, so I've got my calculator over here, and I want to type in the e to the x. All right, I'm typing in the e to the y, but the calculator understands x as the variable. So we're going to type in e to the x here. The best way to do that is to hit the second button, followed by this e to the x right here, which is it's the second function of the natural log. So second button, and then this e to the x here. All right, so as you can see on that line, it says it's got e raised to some power. And then we'll just put an X there by pressing the X button. So now we have e to the x. And then we're going to go to our table. So press the table button. And we're looking for the values from -3 to 3. And that's what we have here. So as you can see, when x is -3, y is 0.049, which we round to 0.05. The only difference is that these x's are actually our y's, and the y's that you see in the calculator are actually going to be the x's on the table. All right, so when y is -2, x is going to be 0.14, which is what we have here. When y is -1, x is going to be 0.37, which is what we have here, and so on. Right? We're just copying all the values that we see from the calculator. All right, back here on the page, we don't have a coefficient in front of the natural log, so we can leave the ay blank. And let's just go ahead and plot those points and draw the curve. All right, so this is what the parent curve looks like. Now let's talk about the transformation. We know that the x minus 1 moves it to the right, and then the -2 moves it down. So the transformation is to the right 1 and down 2. Let's apply the transformation to all the points here, including the vertical asymptote. So everything moved to the right 1 and also down 2. All right, so that red curve is your graph. And now let's talk about the domain, range, and vertical asymptote. The domain is going to go from the vertical asymptote to infinity, so that's 1 to infinity. Range is -infinity to infinity because it goes down and up forever. And as we said, the vertical asymptote is at x is equal to 1. All right, that concludes the lesson on the exponentials and log graphs. And you can go ahead and finish the rest of these problems. Go ahead and finish all of the even questions.